Oh, oh.
What's wrong?
Oh, tea's too hot, Wayne. I can't drink this.
Oh, tea is quite hot, you're
Are
right.
you not hurting yourself? You fine?
I'm northern.
Oh, yes.
We drink a lot of...
No sense, no feeling, yeah.
Yeah.
So, now on to temperature.
Yeah, so we start off with thermal equilibrium.
So, what's that?
Well, it's pretty much exactly like it sounds actually. Thermal being within heat, and equilibrium is when it's equal.
So you can think about it in terms of the sun, which is this big orange pen again.
Oh, I like orange. I don't have orange.
Only Eddings, I think, was that one. Yeah. And that's our sun. That's what it looks like. You look up at the sky, don't
Do that, really
but
bad.
it looks like that.
Then you've got the Earth somewhere down here, and then green.
Light shining towards it. And the Earth is sending thermal energy to the sun.
Yeah, and the sun is sending a hell of a lot back to it, because the
Yeah.
sun is a lot hotter than the Earth.
Yes.
And that's sort of on a big, grand scale.
Mm-hmm.
If you hold, I can't draw a hand, this is a hand.
That's a lovely hand, Wayne.
If you hold an ice cube, you know the ice cube's going to melt.
Yeah, and the water will warm up to the temperature of your hand, but your hand also cools down.
Yeah.
And this is the equilibrium being reached.
Yes, the heat shifting between the two things, essentially.
Yeah.
And then they reach thermal equilibrium is when they both reach the same temperature.
Yeah, and
So-
this will be somewhere in the middle of this space as opposed to the sun reaching the same temperature.
Yeah, yeah. It's a bit different.
Bit different.
That's very, very hot.
Don't put that in your tea. But yeah, yes, go on.
So we measure temperature in degrees Celsius. Is there any other measurements of?
Yeah, I think there is. So there's Fahrenheit,
Of course.
Rotmer, Bremer, Delis, Rankine.
Wow, you know a lot
Newton.
more than I was.
Yeah.
Wow.
Yeah.
I was more going for Kelvin actually.
Oh, I forgot about Kelvin.
So there's this temperature called, there's a temperature scale, sorry,
Yeah.
called Kelvin.
And it was one of the first to use well, not one of the first, but it's one of the ones using an absolute value, so it has absolute ends that hasn't really got a top, but it has a starting point.
So what we need to establish is why is degrees Celsius what it is? What is degrees Celsius based on? And
Yeah.
why is that terrible?
So degrees Celsius is based on water, so that's why when it's 0, water freezes,
Yeah.
and when 100, when it boils, it's not a coincidence, it's what it based it on.
Yeah, a guy just said, we'll make that 0 and that 100.
And
And
we'll
we'll divide it up into
divide it up
100
into-
little parts.
So Kelvin's a bit like that. The distance between 0 and 1 would be the same between each Kelvin.
But they didn't take naught to be the freezing point of a random chemical. Because
No.
water, though it's obviously important and we all know that, it is really just a random
Yeah.
chemical.
Because you have mathematical problems. What's the twice the temperature of 0? Well, it's not 0.
No.
Because that's a temperature. You have to have sort of an amount of energy, and that's what Kelvin's thinking about.
Yeah, so Kelvin took 0 to be as cold as you could possibly get, or absolute 0.
Yeah, and that's where that phrase comes from. You have to work out what would that be, and that's where our ideal gas comes in.
Yeah.
So when it is absolute 0, it does occupy no space, and that's sort of where it's defined.
And there's some clever graph interpolations of different things.
Yeah,
that
they
you
all
sort
end
of
up
treat
there,
ideal
which is
gas.
quite nice.
And it comes to 0 Kelvin, that's not okay, that's 0
Yeah,
Kelvin.
it's not right.
It equals minus 273 degrees Celsius.
That's great.
Yes. Centigrade.
So that means that 0, melting point of ice, would be 273 degrees Kelvin.
Yeah.
So you get quite high numbers when you're thinking of Kelvin in general.
But Kelvin actually means something more, because
Yeah.
it's got this as cold as you can get. And like Triff said, there isn't really a limit to how hot you can get.
Not that we've noticed.
Not that we've noticed.
It gets very, very hot.
But you cannot get colder than this temperature.
No. Or even reach it. We've got very close, I
We've
think.
got pretty damn
In a
close.
millionth of the degree,
Yeah.
but we haven't actually reached it.
And that's the Kelvin scale.
Yeah.
I don't know what other scales you're on about there, but they sound great. Fahrenheit is terrible.
Fahrenheit, I don't like Fahrenheit. Although it was quite an early one.
Yeah.
17 something. Right around there, actually. There's lots of French ones. The French seem to like temperature.
Yeah. What's really funny is typing it into Google Translate and getting it to read it.
Oh yes. Oh, more.